Yes. See that between 2 and 3, you have the peak 2.45. Exactly between 2 and 3, you have the peak. And you see the blue color is blue one is data and red one is fit. Data means the exact transfer function from the circuit. That is your blue thing. And the fitted one is the polynomial fit which was done. And they are coming to say that the both the exact one and the fit is going to be perfectly matching. That is the first observation. Okay. So you are going to design using MATLAB and you are going to fit an approximate polynomial to the same bandpass filter, and you are going to see whether both are going to be same. Okay. So now this portion, now see, I'm going to give an input signal. We have to test, right? So just because the filter response is perfect, you cannot say the filter is doing good. So you have to send some signal and verify whether the circuit is working or not, right? So for that, see, I'm going to send a signal of frequency. I'm going to send a signal of frequency 2.35 gigahertz. The center frequency is 2.45. Actually, this 2.35 should be blocked. Okay, so you know that frequency has to be blocked because my circuit will send only 2.45 gigahertz frequency. So we will see here, and I'm keeping it as F blocker. Just to give a proper name, I'm giving it as F blocker. Okay, so this is my input signal. Input signal will be exactly at 2.45, and this signal is going to be my signal which is going to be blocked up. Okay, now see here, I'm generating sine wave 2 pi ft using the center frequency, that is my input signal, and I am creating a sine wave with noise at the blocker frequency. So if I'm going to end this signal, input plus noise, so input at 2.45 G, noise at 2.35 G, plus I'm adding Gaussian random noise. So if I'm going to send this signal to my bandpass filter, what is my response? So naturally, what should happen? If I send two frequencies, one frequency is within the filter center frequency, other frequency is outside the center frequency. So the frequency which is outside the center frequency will be blocked. The center frequency component will be allowed. That is the thing you are expecting, right? So we will see whether that is happening here. So I am finding input plus noise. Okay, I am generating a sine wave at time. Maybe if you want to see the signal, we'll give the plot command. We'll give the plot command and see if they are able to visualize the signal. Plot t comma input. This is the input. Next one, plot t comma noisy input. Noisy input will have signal plus noise, right? So I'm just running this portion. This is your sine wave, now input sine wave, perfect sine wave. Maybe if I zoom it, you will be able to appreciate that and see the sine wave. Able to see a pakka sine wave. See, the time period is very, very small for you to visualize. That's why it is not coming as a perfect sine wave. Okay, and this one is a noisy sine wave. If you zoom it, it's actually sine wave mixed with random Gaussian noise. So if it may look like sine wave, but it is actually having a lot of noise. Okay, so I have just plotted this. So this command is not as a part of the code, but I have just plotted this just to show you how the input and noisy input